Hello, welcome to Science Chomp. Today we're going to be talking about fossils. I've divided this up into a series of questions to make it slightly easier, so let's get right into it. First of all, what are they? Fossils are the preserved remains of dead organisms. Not every single organism can fossilize. Certain requirements need to be met. Which leads us on to our next question: what conditions are needed? Well, first of all, the organism needs to be away from anything that's going to eat it. So it needs to be buried and buried quick. Ideally, it needs hard parts as well. Okay, so soft tissue doesn't really fossilize particularly well because it rots. Which leads us on to our next set of conditions. Because microorganisms decay soft tissue really well, what you need to do is you need to eliminate these microorganisms. So these are things like bacteria and fungi. So bacteria and fungi, like you and I, require a bunch of things. First of all, it requires warmth, it requires water, and it requires oxygen. Okay, so if you eliminate any of those, you're not going to get those microorganisms. Okay, so fossilization occurs particularly well in freezing conditions, in arid conditions, and in oxygen-free environments. The third question is, how are fossils preserved? So there are a bunch of techniques, bunch of ways in which fossils can be preserved. The first type, they're called preserved remains. I've got my notes here. Cut! So this leads us on to our next question: how are fossils preserved? Now, there's a bunch of different ways, and the first one is called preserved remains. And as the name suggests, these are organisms that have changed very little from when they died. So an example would be if an insect was to land on a tree and then tree sap covered it. Well, it would look exactly the same for thousands upon thousands, maybe millions of years. Okay, we've also found encased in ice examples of things like people and mammoths and things. Okay, the next one on my list is carbon films. Now, all organisms contain carbon, and what happens is an organism would die and it would lay down on a rock. And as everything else disappears through rotting, what's remained is carbon. And this forms an imprint onto the rock, and this is called a carbon film. And that process is called carbonization. Okay? The next one on my list is mineral replacement. Now, minerals are inorganic substances found naturally within the earth. And we all have them, for example, things like calcium and this sort of thing. And what happens is when an organism dies, groundwater comes in contact with the organism and it reaches the hard parts, and eventually the minerals get replaced with the minerals in the groundwater. So an example would be, for example, a shell which is made of calcite getting replaced with silica. Okay, so that's an example of mineral replacement. Essentially what happens is the fossil turns into stone. Okay. The next one on the list is molds and casts. Now this comes together. Now this is when you have none of the original organism left in your fossil. So you may be thinking, how is it a fossil? Well, what it is, if you grab a seashell and press it into some sand, you're going to be left with an impression of the seashell. Now, over time, this impression is going to harden up, and the shell itself, the original seashell, might erode away. So that impression, that's called a mold. And when that mold is filled up with sediment, and then that sediment hardens up, you end up with a cast. Now remember, these aren't actually the original organism, it just looks like it. So that is casts and molds, okay? And then finally, we've got trace fossil. And again, now trace fossil, there's no organism left there at all, and not even an impression of the whole organism. But what you find are things like trails, footprints, tunneling burrows, which are evidence that an organism existed. Okay? So that leads us to our next question. What can we learn from fossils? Now, a person that studies fossils is called a paleontologist, and there's many things that we can learn from fossils. First of all, it gives us evidence for evolution occurring. Fossils are found in rock, and the deeper a fossil is within a rock, the older that particular fossil is. And this also gives us evidence of mass extinction events. For example, if you have like 1,000 fossils very, very deep down in some rock, and then on top you've suddenly gone from 1,000 to 15, and then slowly you get more and more, it tells you between the two rock layers you've had something like a mass extinction event. This could be something like a meteorite or like a volcano, something which has wiped out a whole bunch of organisms. Other things that we can find out from fossils are basically what the previous climate used to be like. Now, if a fossil is very similar to a modern organism, we can basically tell that that ancient organism used to live in a very similar environment to the modern one. We've found fossils in the past of tropical plants, and if you find fossils of tropical plants, you know that where you found it, that used to be a tropical warm environment. Similarly, we've found fossils of mammoths. So where we found the mammoths, we know that that particular part of the world used to be much colder than what it is now. By studying fossils, we've also figured out how dinosaurs used to live. And when the dinosaurs roamed the earth was very warm with lots of tropical forests and swamps. Okay? That's basically it for fossils. I know I had to read a lot from my notes, but that's because I kept fumbling my words. Apologies for that. I'll see you in the next video. Goodbye.